Hello class, we're about to start section 7.7, Finding Quadratic Models. Note, this section will help you with your applications of modeling lab. Example 1. Let f of t be the average annual expenditure in thousands of dollars for people in the U.S. at t years of age. And this is data from the 2012 U.S. Statistical Abstract. Okay, so we have our values here. Now we have it from under 25 all the way up to 75 and older. Okay, now it says consider a scattergram of the data. Is it better to use a linear, exponential, or quadratic function to model these data? Explain. Okay, you look here. If we look at this model here, if we connect this looks more like a parabola. So actually, we know that a parabola deals with a quadratic function. So this is best represented by a quadratic function. The data goes up and then back down. Okay, now we scroll down here to B. It says B, find a quadratic regression model for f of t with your calculator. Give 3 decimal places. Now, when we go to find our regression model, we would go back up to the top here, and we would enter in these values, the representative age and the average annual expenditure. And then we will put those values into our L1 and L2, and then we will go to math, and then over to we will go to stat, then over to calculate, and then press the number 5. And it will give us this value here. We have f of t is equal to a negative 0.032 t squared plus 3.154 t minus 20.721. And this will be our final answer. Now it says here, explain how you could verify that the model found in B fits the data well. Now I took the liberty of putting this graph here, but you would just go to plot 1 and turn it on, and then you would press zoom 9, and then the graph comes close to all points. So basically, you will put this formula in here, and you would turn plot 1 on, zoom 9, and then you will see that the graph comes close to all of the points. And this is just a representative model. Okay, now we go to the next page, page 28. These are calculator instructions to show you how you will go about doing a problem like we just did. So you could read this at your leisure to get your answers. You see here, when you get your quadratic regression, you get an A, B, and C. And we know quadratics go ax squared plus bx plus c equals 0. So we'll know where to substitute in these values. Now we will go to the next page. The next page, we will have our Microsoft Excel instructions, which you could also try this on Microsoft Excel. And if you need additional instructions, we have the website right here. So you could do this website. Now remember, this is an underscore. At this 131, it'll be underscore tech. And you could type that in and you could get the video tutorial. Now we come here to our next page. We got the regression recap. Now I took the liberty of copying this and putting in these values here, and I will explain this to you. Okay, now we have the different types of regression. We have linear, exponential, and quadratic. Okay, now we know linear is mx plus b, exponential is ab to the x, and quadratic is ax squared plus bx plus c. Now, we would take a look here. Now, we know we're dealing with regression lines and everything like that, so the points typically are not exact. Like here, we will have points form a line-ish, like some form of a line, and then it will cross the x-axis and give negative predictions, which we will show here. Now the exponential, we know that forms some form of a slight curve, the points curve, and it increases extremely rapidly if b is greater than 1, decreases if b is greater than 0 but less than 1. It's very steep, never be 0 or negative. These are just a few characteristics we went over in previous lessons. Now with the quadratic, it forms a U shape. It's not just a curve, it has to be a specific U-type shape. And it will often make wild extrapolation predictions because of the parabola shape, as we see here. And it also crosses the x-axis and also can go into the negative area as well. Now, we can have two ways to check which model fits best. The scattergram, which model comes closest to all the points when graphing the model? Which model has a r-squared closest to 1? And then which model does the best job of extrapolating past the data points? So we have capital R-squared or lowercase r-squared is called the coefficient of determination. It's a number between 0 and 1 that gauges how good a fit the model is for the data. The closer to 1, the better the model. Example 2. What is the r-squared value for the average annual expenditure data set? 3 decimal places. What does this tell us about our quadratic regression model? So, this is what we will have. Okay, so our answer here would be r-squared is equal to 0.97. It's equal to 0.970, and it's the quadratic. The quadratic model was really good. For our data. Because we know 0.970 is really close to 1. Okay, now, this is our final answer. Now, you may wonder how I got this answer. Now, this is how I got this answer. After you typed in all of your L1 and L2, these are the instructions you would need to do in your calculator. Once you follow these instructions, you could pick which one of these you want, the linear regression, exponential regression, or quadratic regression, which we would pick the quadratic regression. And you notice here, even though we use the small r with the quadratic regression, it uses the capital R squared, but it still means the same thing as the lowercase r in this case. So, now of course this use different numbers, but you get the gist of it. So all you have to do is look at this, read this, or look at the video at your leisure to understand how to get the r squared, or the coefficient of determination. And then you could also do that in Excel, and here's the video tutorial. Now, we scroll to the next page. We have example 3. it says, consider the FBI burglary data set again from chapter 2. 3 different scattergrams are with 3 different models, and R-squared values are given. Okay, now we have our burglary rate. If we look here, we can see that this is y is equal to mx plus b. This is linear. We need to look at these equations. Now, we look here at this equation. We have y is equal to 1089.4 e to the negative 0.024x. So we know that this is actually in the form of an exponential. This is actually exponential, because we know e to the negative, well, this negative power here, will actually, if we put it in a calculator, this will end up becoming y is equal to, well, let me get me some more room. This will give us y is equal to, we'll still have 1089.4, but the e to this negative 0.024 power, that would give us 0.976. And then that would be to the x. So we will have this in a y equals ab to the x form. That's why we know this is exponential. Now we come down here to the next problem. The burglary rate in the U.S., if you notice here, this is forming more of a parabola shape. So this would be quadratic. And based upon the formula here, we know we have ax squared minus, or we could say plus a negative bx plus c. So we know that this is quadratic. Now, the next thing we will have, it says down here, label each graph as linear, exponential, or quadratic. We did that already. So B, judging by the model fitting the scattergram, which model appears to do the best job? And as you see, more like the quadratic, because it's hitting more of the points than the other 2 graphs. So we will put quadratic. And that's because it's closer to all points. I don't know why a lot of these letters keep disappearing, but we just have to deal with it for right now. So it's closer to all points, and it's quadratic. Okay, now C, it says, does the R-squared value support the answer for part B? And we would have to say yes, because after you put in these values, your R-squared would equal to 0.9674, and it would give you the highest of all 3 for a quadratic. Now all you have to do is fill in your L1 and L2. Now L1, we will actually start this, we're assuming that it's starting from 1990. So 1990 would be 0, so we know this would be 2, 4, 6, and so on. So this would be our L1, and the burglary rate will be our L2, and you will put that in your calculator. Now we come down here to D. It says, which model will make the best prediction past t is equal to 22?